0 treating zeros. So for this problem, we are giving a number n, so this n going to be an integer, so we're going to return the number of treating zeros in n factorial. So for example, factorial of n equal to 3, which is going to be 6, and there's no treating 0. But the factorial of 5, it is 120, so there's going to be 1 treating 0, so we're going to return 1. And similarly for n, if n equal to 0, factorial of n equal to 1, and there's no treating 0, so we're going to return a 0. How can we solve this problem? So if some number with a treating 0, so for example, all those numbers is not 0. It may be from 1 to 9, and after that it's going to be treating zeros. Yeah. So we need to think about which numbers is related to treating zeros. Definitely it is 10. So if I have a 10, it is a treating 0. If I have 100, definitely there are 2 treating zeros. Yeah, definitely it's going to be a 10. But what about number 5? So 2 times 5 is going to be 10. Yeah, so if we know how many 5 for the number, for the factorial of this number, if it, yeah, so for example, if n equal to maybe 5, so 1 times 2 times 3 times 4 and times 5. If we know how many numbers of 5, do we know how many numbers of 2? Yeah, because for example, this 4 is going to be 2 times 2. So definitely there will be more 2's than the number of 5's. So up to 1 to 5, there's only 1 5, but there's 3 2's. And we can continue to do that. So maybe 6, 7, 8. So there are going to be more 2's instead of zeros, instead of 5, and 9, and 10. So up to 10, we have another 5, but we have more 2's. As you can see, there are going to always be more 2's than the number of 5. So this means that if we know the number of 5 from 1 to n, so definitely we know how many zeros. So this is the idea. So even though I cannot prove that, because it's going to be really difficult, but we're going to just use this kind of conclusion to solve the problem. As you can see from the example, because 2 is a smaller number, and there's going to always be more number of 2's than number of 5. So this means we can just check how many 5 from 1 to n, and then we know how many zeros. So the number of 0, the number of treating 0 going to be the number of 5. Yeah. So let's just solve that. So the result is going to be 0. So for I in range from 1 to n plus 1, because we're going to check factorial of n, so it's going to be starting from 1 to n plus 1. And then we're going to check now we're going to check how many number of 5. So yeah, let's just use if check. So if I modular 5 equal to 0, so definitely from here, which means we're going to check how many number of 5 here. So result going to plus equal to I divided, so result going to plus equal to 1, and I going to equal to I modular 5. So here we're going to use a while loop. So while it meets the condition, we're going to check the result. And finally, we just need to return the result. So this is for checking from 1 to n plus 1 how many zeros. Yeah. Now let me just submit it to check if it works. As you can see, it works and it passes for all testing cases, but this is the n log n time complexity for the problem. N is 10 to the power 4. Definitely it works, but this is not a good solution. So the good solution is that could you solve a solution that works in logarithmic time complexity? So what is logarithmic time complexity? So definitely we should not use a for loop. Yeah, can we solve it without a for loop? We're gonna just solve it in log n time. Of course we can. So we're gonna use it this way. We're gonna directly check this number, and we're gonna update this number with n divided by 5. Yeah, and this n is gonna be divided by 5. So this means for any number, so for example, if this n is 5, what are we gonna do? We just need to check n divided by 5, so it's gonna be 1. It means there's gonna be 1 0. So what about n equals to 10? If n equals to 10, what happens? So the result plus n divided by 2, so the result is going to be 2, and this n divided by 5 going to be 2. Yeah, so if n equal to 10, there are going to be 2 zeros according to our calculation. Yeah, so let me just submit it to TAC. As you can see, it works. Now let's just try a testing case. Maybe we want to try, instead of 6, we want to try a 10. So what's going to be the final result? Let's just check that. Yeah, as you can see, for this number 10, it's going to be 2 zeros. It means our calculation is right. Yeah, so definitely this is going to be a better solution. And it's going to be log n time complexity for the problem. As you can see, it's going to be really fast. It is 100% of all submissions. Yeah, I think that's all about it. Yeah, maybe I need to explain, if this n equal to 11, what are we going to do? Because if n equal to 11, definitely there are going to be some numbers from 1 to 10. It has already been calculated. So we can still use this formula to check. Yeah, it's going to be, first of all, it's going to be n divided by 5, it's going to be 2 zeros, and n divided by 5, n equal to 2, and it's going to be 2 zeros as well. Yeah, so this means the calculation is going to be really easy if we use this kind of calculation. I think that's all about it. Thanks for watching. See you next time.